Remember, if you know some complex analysis, that the exponential of I alpha is cosine alpha plus I sine alpha. Okay? And remember that the rules for multiplication stays the same with some quite tiny modification when we're dealing with the square root. So when we do the exponential of a I alpha times a I beta, so we get cosine alpha plus I sine alpha times cosine beta plus I sine beta. Okay, but here it's just the exponential of I alpha plus beta. Okay, but here we do the multiplication the usual way. We get cosine alpha cosine beta plus I cosine alpha sine beta plus I sine alpha cosine beta plus I times I is I squared, which is minus 1. So minus sine alpha sine beta. Okay, so we collect the real terms with the real terms and the imaginary part with the imaginary part. We get cosine alpha cosine beta minus sine alpha sine beta. Okay, plus I cosine alpha sine beta plus sine alpha cosine beta. But this one here, according to this definition here, what's this one here? So it's the this one here is cosine alpha plus beta plus I sine alpha plus beta. And we said earlier in one of the short videos is that when we have two complex numbers, let's say z sub 1, z sub 2, okay, these two complex numbers are equal when the real part of z1 is equal to the real part of z2 and the imaginary part of z1 is equal to the imaginary part of z2. We can prove it later. We're gonna upload more videos concerning the algebra of complex analysis, and we're gonna see how to prove that one quickly. Okay, so we use this key fact here. So the real part is this one should equal the real part here, which is cosine of alpha plus beta. So it's cosine alpha cosine beta minus sine alpha sine beta. So that's what we know. The sine is this here. Imaginary part in this part should equal the imaginary part here. So the sine of alpha plus beta is cosine alpha sine beta plus sine alpha cosine beta. So we get the usual result that we know already. This is another way of proving that. So we showed that the cosine, let me write it down here to make it more, well, you have more space. So cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And we know that the cosine is selfish. Always start with two angles and you subtract the sine. The sine is nice. Sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Is nice. Always switch, doesn't switch the sine, or always takes the cosine with him. But the cosine is selfish. So we need to remember these two results because we want to see when alpha is beta, what's gonna happen, and when alpha equals beta equals 1/2 or something like this. So these results can be very important for us, but for now this is another quick way of proving this formula for the sum using complex analysis. We will add more videos concerning this one, where we need to do more work. We need to do more problem solving to be able to learn all this complex stuff. Thank you.